Question 18 is asking us to show that the following three lines are concurrent. And so for these lines to be concurrent, that means that they all must intersect at the same point. So we want to find an x and y value that work for all three of these equations, and then that's going to be the point that they intersect at. So to start out with, I'm going to look at the second equation, which is x plus y equals 1, because this one's nice and simple. And with my first equation, y equals 2x plus 10, I have a nice expression for y in terms of x. So what I'm going to do is plug this in for y in this equation. So this gives me x plus 2x plus 10 equals 1. And so now I have an equation that's all in terms of x, and I can solve for x. So x plus 2x is 3x, and I have plus 10 equals 1. And now I'm going to subtract 10 on both sides of my equation. This gives me 3x equals negative 9. And then dividing both sides of my equation by 3 gives me x equals negative 3. So now what I can do is plug this back into this equation here. So this gives me y equals 2 times negative 3, because I'm plugging negative 3 for x, plus 10. And so now I'm going to solve for y. This gives me y equals negative 6 plus 10, and negative 6 plus 10 is positive 4, so this gives me y equals 4. So I have x equals negative 3, y equals 4. For my x and y values that fit both of these first two equations. Now I want to check this with the last equation to make sure that this is also a point on that line. So what I'm going to do is I have y equals 7x plus 25. And I'm going to plug in my values for x and y and see if my two sides of the equation stay equal to each other. So this is 4 equals 7 times negative 3 plus 25. 7 times negative 3 is negative 21 plus 25, and negative 21 plus 25 is positive 4. So yes, this works out, and the point x equals negative 3, y equals 4 is a point where all three of these lines intersect, and so they are concurrent.